Okay, so we're going to go through a quick video here on characteristics of exponential functions. So we've already done characteristics of quadratics. We did that for a long time. And we also did characteristics of linear functions, kind of on and off, but you already had some decent ideas about that. So let's go with one example here, and you have a fever for tonight, on a couple of characteristics. So I'm not going to go through them all, but there are less because odd or even doesn't really apply here. And a couple other things don't apply either. So let's just go from the beginning. So this is the base function f of x equals 2 to the x power. First characteristic is it a function? But obviously it is. I'm not going to give you one that isn't. Next characteristic is, what's the domain of this function? Well, remember, domain is from left to right on the x-axis, right? So this function begins at negative infinity, and it goes to positive infinity on the x-axis. Although it's going up, it's also going to the right. So the domain of this function is all real numbers, or negative infinity to positive infinity. And remember, when we do the infinities, we have to use parentheses because it actually can never attain infinity. Infinity is an idea. Okay, so the range of this function, that's where it gets a little tricky. Clearly, range is from the y value, so it's going to go down and up. It's going to go to positive infinity on this end. But where does it start? Now remember, we talked about an asymptote. This function will get infinitely close to the line y equals 0, but it will never actually approach that line. It'll never actually touch the x-axis. So we have to use a parentheses and a 0. It will never get to 0, but it is eventually going to get, it is going to get super close to 0. So this is the range of this function. Okay, so be careful on range. That's a tricky one. So we'll go ahead and put a little star there. The intercepts. So let's do the y-intercept first. Now, this we'll talk about more in class, so hopefully you already have a good understanding of this. The y-intercept is going to be 1. The y-intercept is 1 on all base exponential functions, and the reason is this. Let's take the function 2 to the x power. This is what this is. Well, when x is 0, please remember that a y-intercept, the x value, is always going to be 0. If I put in x is 0 here, I get this, 2 to the 0 power. Well, you know your exponent rules, and anything to the 0 power is 1. That's why for all base exponential functions, my y-intercept is going to be 1. Now, if I did a transformation to this, that clearly wouldn't be correct. But if I give you a base function, whether it's 3 to the x, 5 to the x, 6 to the x, and it's positive, it is always going to have that 1 as a y-intercept. Okay? The x-intercept is a little bit tricky until I give you the answer and you figure it out. There is no x-intercept. It will never even touch this line, so how could it ever cross that line? So there is none. Don't write 0 because 0 is a number, and that implies that it's right here at 0. It's not. Next one, end behavior. So just take a minute for you to remember what we do. So end behavior is one way and the other. So you need two different things here. So as x approaches, remember that? Some number, f of x approaches another number. Now, let's go to the right first because that's a little easier. As x approaches positive infinity, which means as x goes forever to the right, what is f of x doing? Well, f of x is also approaching positive infinity because it's going up forever. Now, let's go the other way on that. As x, I want to make sure I don't run out of space. As x approaches negative infinity, okay, so as x goes this way forever, be very careful on what f of x approaches. F of x is going to approach 0 because it's not going to go any further down. It's only going to approach 0, which means it's approaching. Like I'm approaching the phone, I'm approaching the camera right now, but I'm not actually going to get to this camera. Or am I? Okay. I'm approaching it, but I'm actually not getting there. I'm not touching the camera. This line will approach 0, or the x-axis, but never actually get there. So it approaches 0. That's another tricky one, so we'll star that one. Now the asymptote. I want it as a line. You have to tell me it as a line. Well, this is the line. It's the x-axis. Don't write x-axis because that's not correct. The asymptote is y equals 0. And that's this line here, side to side. So that is the barrier line. Remember, an asymptote is a barrier line. It won't ever cross that line. The last characteristic that we'll talk about is AROC, but you already know that. I'm not going to do it on this function now because we're already at 5 minutes, and I want you to get some more practice with some more on the fever form. So domain and range, I'll keep them separate. I'm going to classify the intercepts as one specific characteristic, and behavior can be 4. The asymptote line can be 5. That's a terrible circle. And then A rock would be 6. At this point, these are the only ones I want you to remember. We don't have to do is it a function because it's going to clearly be a function. The only way it wouldn't be is if I give you a rational function, but don't forget I said that. I'm not going to do that for you. There you go. 6 characteristics. So the challenging ones are range, so be careful about range, and then behavior because of which way it's going. Okay? See ya.